how do you find the horizontal asymptote? This part here is the part that is really interesting. It has some simple stuff and some stuff you got to think about. Let's go back to this first problem we had a while ago. The 2x plus 1 over x plus 1. All I want to focus on is the horizontal asymptote. First off, there's the graph. There's the picture of this graph right there. Okay? Now then, to find the horizontal, all we're going to do is this. We're going to look at, it's at y equals 2. 1 second. Here's how we find it. These are the three graphs, and those are where they are right now. This graph here is y equals 3x squared minus 3 over x squared minus 2x minus 4. There's the horizontal there. This graph up here, 4x plus 3, 2x minus 3, y equals 2. There's the horizontal graphs right there. Now, I have drawn them. Let's figure out how they got that horizontal graph. How we could find it if we had to graph it without a calculator. And here's what you do. Go to this right here. Look at the leading coefficients. We talked about leading coefficients the other day. That is the coefficient on the highest degree. The degree on both of this problem right here is just 1, so it's the same. So I'm going to look at that. The coefficient of x. This is not 0, but this is 1. Look at the leading coefficients. The coefficients for that are 2 over 1. Y, so that means y equals 2. Guess where the horizontal asymptote is at? Y equals 2. Think about it. Because there's no number that you could put in here where you're adding these things to it to change the values that will make it ever be 2. So the horizontal asymptote is always found by looking at the leading coefficients. So let's look at problem right here. Our second problem right here. Notice, what is this time we have an x squared and an x squared, right? Those are our highest degrees, so our leading coefficients are this set right here. What are the numbers here? 3, and once again, this one is 1. So the horizontal asymptote is just at 3 over 1. So that means it's at y equals 3. And notice, look where it's at. It's right there at y equals what? 3. That's where the horizontal asymptote is at. That's it. All you have to do is look at the leading coefficients. So look here at problem number 4. For problem 3. 4x plus 3 over 2x minus 3. Look at the degrees are x's. I'm looking at those. So I'm just going to go ignore the x's. Y is what? 4 over 2. So y is just what? 2. A horizontal asymptote here occurred at y equals 2. You just have to look at the leading coefficients. Well, let's look at a different one. Let's look at one that's a little more complex. Uh-oh. What is the problem here? And as you're looking at here I see an x squared and here I see an x. Are the degrees the same? They are not. So don't put 2 over 3 because these are not the same. What you need to do is this. This is a 3x squared, so guess what I need up here? I need an x squared. I need an x squared. So I can just add 0x squared. Now do I have the same degrees? Yes. And notice, 0 over 3 makes what? 0 over 3. And you're going, okay, so y equals 0. But wait a second, Coach Stoney. It's touching the line right here. Yes, it is. But an asymptote, by definition, means as you approach the infinities, or close to 0, or whatever number that makes it 0, it goes on forever. And if you'll notice, 0 is an answer one time, right here, but then it's going to go, and these numbers here are going to get closer and closer to infinity, but it will never touch this line again out there. That's why it's still considered to be an asymptote. So you can have a horizontal asymptote that still has one answer, but as it approaches the infinity areas, as you get larger and larger to infinity, your answer gets closer and closer to 0. I know, that's confusing for me too, because I think of asymptotes, can't touch this. Can't touch this, but it's actually can't touch this in this particular sense as you're moving towards the infinity values. Okay? So this one is unique. You will not have many like this, but you will see this occasionally. All right, so the asymptote, though, is still at y equals 0 on this particular one. Let's look at another trickier one. So I have 2x squared over x squared. So, ooh. Well, first off, if I'm just looking for the horizontal asymptote, let's look at this. Notice, do I have the same degrees? I do. And that would be 2 over 1, meaning the horizontal asymptote is at y equals 2. So to find the horizontal asymptote, you have to look at the leading coefficients, and the degrees have to be the same. If they are not the same, you need to make one of them the same, which you can simply get by adding a 0x squared, a 0x cubed, whatever it takes to make it work. Okay, go ahead and stop at Windsor.